Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're focusing on problem 51 in this video, and that comes from either Lesson 10.2 or Lesson 10.4. And at first glance, those might seem unconnected because 10.2 discusses completing the square, and 10.4 is all about the quadratic formula. So I'm actually going to label both of these methods because we're going to go through both of them. The way that they probably want you to do this problem is with completing the square. And the reason that I'm thinking that is because the answers all have square roots. And we should know that when we have an answer of a square root, and I'll do this up here, that means no factoring, or if you call it the box, no box. Okay? So, completing the square is one option. The reason I'm thinking it's completing the square over the quadratic formula, even though they both work and they'll both get you the answer, is the quadratic formula is that, and I'm going to rewrite it for us right here anyways, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. The quadratic formula has that over 2a part, and none of these guys do. I'll show you how we simplify the quadratic formula to get to those answers, but what that means is there's probably going to be a little bit more work on the quadratic formula, but you could also argue, no, I know the quadratic formula, it's not more work, and that's fine. I'll show you both methods. We'll start with completing the square. To complete the square to solve an equation, we need to first turn this guy into a perfect square trinomial, because I already said that you can't factor here, and that's a little bit wrong. Because you can't factor this equation nicely, but we can turn it into an equation that does factor nicely. That's the completing the square part. So if you might remember, to complete the square, we just focus on the x squared plus 4x part, and we leave the minus 8 and the equal to 0 by itself. And actually, I'll just do it like this. Okay. To find the number that goes in here, we do half of b and square it. 2 squared, which gives us plus 4. The reason we do that is because that is something that is super easy to factor. It is just x plus half of b squared. You can use the box here if you'd like. You can use your factoring. What multiplies to make 4 adds to make 4, but it's generally just faster to say, oh, it's x plus 2 squared. That's the whole point of completing the square. Then we still have, of course, our minus 8 and our equals 0. But wait, we've talked about balance in the past. If you just randomly add 4 to this side of the equation right here, it unbalances our equation. Everything's not equal. Now in a past video we said, well, if you add 4, you can just subtract 4. But the other thing you can do is if you add 4 to one side, you could just add 4 to the other side. And that keeps everything balanced. So, what do we do now? Well, now there's only a single x in this problem. Up above, we couldn't solve earlier because we had 2 different x's. Whenever you have 2 different x's, SADMAP is not your friend. A lot of times it is factoring, but we discussed why there's no factoring on this one. And so we had completing the square quadratic formula. But now we're down to a single x, so to me, now we're down to SADMAP. Okay, let's quickly identify everything that's attached to the x. There's an 8 that's subtracting. We'll undo that one first. There's a square, that's an exponent. And there's a 2 that's adding, but that's inside the parentheses, so we have to do that last. So let's work top to bottom, and we'll start by adding 8. Add 8 to its like term, and we end up with, well, x plus 2 squared, and then 0 plus 4 is 4, 4 plus 8 is 12. From here, we need to undo the square, since we already took care of the addition and subtraction. No multiplication and division. Undoing the square requires a square root. X plus 2 equals, and then don't forget when we introduce the square root, we do need a plus minus out front. Now, the square root of 12 does not have a nice square root, right? It's irrational. And we know that because 2 times 2 is 4, 3 times 3 is 9, 4 times 4, hopefully it's 12. Ah, it's 16. We skipped over 12. So the square root of 12, if you use your calculator, is something 3 point something. However, we're not going to use our calculator here because if you look at the answer choices, there are no decimals in the answer choices. They clearly kept their square root. So I'm going to keep the square root of 12 throughout. The last thing we need to undo is what was in the parentheses, which is the 2. So I'm going to go ahead and subtract 2 from each side. Now we need to remember that negative 2 and square root of 12 are not like terms. The 12 is in the square root, the 2 is not. So the negative 2 is just going to hang out right next to the plus minus square root of 12. And this guy right here is our answer. But what's the issue? Well, there's no square root of 12 up here, is there? So how did they turn the square root of 12 into what definitely looks like the square root of 3? Well, they did everybody's favorite technique, and I'll just kind of work this in the middle right here. I think it'll work out okay. They broke down the square root of 12. Okay? To break it down, most students, I think, fully break it down, so I'll show that. 6 and 2, 3 and 2, and we can notice that there is a pair of 2's and a loner 3. The pair of 2's go on the outside of the square root. The loner 3 goes on the inside. And so we have x equals negative 2 plus minus no longer the square root of 12, but now 2 square roots of 3. And I hope this matches an answer. Negative 2 plus 2 square roots of 3, and it does. It matches answer choice A. Complete the square, break down the square root. A decent number of steps, though. So you might be thinking, well, you said that they probably preferred you to complete the square. I think quadratic formula is easier. And honestly, it might be, depending on how you view it. So let's do the quadratic formula. All right, we know A is 1. I can label this, I guess. B is 4. Should have gotten the sign there. Oh well. And C is negative 8. So let's plug all these in. And I'll leave the blanks first, and then we'll go back through and do it. I always put parentheses with the quadratic formula. I think it helps you with all the different signs and not missing those. Let's see, so B is 4. A was 1. Let's see, it's all over 2A. Very nice. And C was negative 8. Okay, so let's go ahead and simplify. Remember, most of this simplifying should probably be done with your calculator so you don't make a mistake. I'm seeing 16 right here, and then this will be a plus 32. 16 and 32, I think, is 48. All right. Now you'll notice this doesn't match anything yet, and we're not going to divide yet because technically there's an invisible 1 here, and when we divide the 2 needs to divide to both of these, and 2 doesn't go nicely into 1. So instead, I think we're going to have to break down that square root of 48, which is a bummer because I did 12 over here, and I was hoping it'd be 12 again, but it was not. So let's do 48. Write a little bit smaller. Okay, 48, well, I know it's 12 times 4, and that's 2 and 2. 12 is 4 and 3. I did 6 and 2 last time. We're just switching it up here. 2 and 2. So we have a pair of 2's, loner 3. Each pair of 2's is going to go on the outside, and that leftover 3 goes on the inside. And so if you clean this up, this to me looks like 4 times the square root of 3. So let's go ahead and take that x equals, keep everything as is, but instead of the square root of 48, it is being replaced with 4 square roots of 3. You could, if you wanted, keep the 1 outside, but 1 times 4, that's just 4, right? So no reason to write the 1. All right, but we're not quite there yet. What we need to do now is we need to distribute the division. So negative 4 divided by 2 plus minus 4 square roots of 3 divided by 2. And so we end up with negative 2 plus minus 2 square roots of 3. Ta-da! I think that matches the same answer we got over here. It does, and probably the same number of steps. Arguably, the completing the square had that trickier step in the middle, but the quadratic formula also had you break down a larger number and then have to remember to distribute the division. So neither way is super straightforward. It's a pretty tricky question overall, but you should see that we can do it in either way. Thank you for tuning in, and hopefully this helps you find success on your Semester 2 final exam.